Reko Kiran. Just wanted to make a quick video about a near field interactions of vertical versus dipole because we normally do not see those type of interfering patterns near these antennas, and we go by certain assumptions that we are always having a flat land near to the antenna, and the antenna pattern is exactly the way in which theory says. So in this particular screen, which I'm showing from 4NAC2 software, I've designed one simple vertical antenna with the four elevated radials out here for 7 megahertz band. This is a very typical situation in my field. Plot for this looks similar to this particular graph out here, whereas between 60 and 90 degrees, that is around 30 degrees, there is a maximum radiation, and as you go towards 45 degrees, it's almost negative dBs. There is no relatively there is no radiation happening towards the sky. So this is not a very good antenna for regional communication or local communication, but it is a great antenna, very simple effective antenna for the DX, provided you have very clear path around this particular vertical. Normally what happens is when we have any obstructions in the path, for example, when we are talking about this particular plot, if I am having between 0 and 30 degrees, if there is a building very nearby, when I say nearby, within 2 to 3 wavelengths of distance from the vertical antenna here, maximum energy gets absorbed or diffracted in a direction which you don't want. So in my typical application where I carried simple vertical antennas, what happened was there were around 15 to 20 feet high buildings very close, within 20 to 30 meters from the vertical. And that is actually a big obstruction. I could always see that very high angle signals only getting through such areas, and there is no DX low angle coming within first 20 degrees reaching my antenna. That is number one thing which I have learned. So when we are talking about any vertical, let it be in the clear or elevate the entire ground plane with the vertical element to an height which clears any nearby obstructing structures like metallic objects or the roofs or nearby buildings or even densely populated trees and all, right? In the rainy season may create a lot of dampening effects on HF, especially if they are the leaves and the branches are very near to your vertical element. So the placement of vertical becomes very important aspect in vertical. This particular antenna, it should be in as much clear space as possible, as much high as possible. The nearer to the sea coast is better. To talk about that, we will go and simulate this in the sea water type of a ground condition. Now I had mini neck ground in good soil condition. Now we will select sea water as the ground below this particular antenna. Within 15 degrees of elevation has grown from a dB and half to now around 5.6 dB, 5.75 dBs, which is a remarkable improvement. It is like having a booster in this area of low elevation angle. Taking advantage of refraction and reflection from the sea plane. So how far an antenna can be from the sea coast or the salt water makes a big difference. It is found that within a quarter wave of distance, if the vertical is placed, there is a significant improvement like this around 5 dBs in the lower side of the elevation, which actually gives a boost to the long range communication. Whereas if you move away even half wavelength or more, the benefits of that will be lost. We have to be right on the edge of the water if we want to take advantage of salt water conditions. Now let us take this simple dipole for 40-meter band. This is at 10-meter high, that is a quarter wavelength high above a good ground, and we will run far field pattern for this particular antenna. We can see that there is a significant lobe towards sky, which it makes a very good NVS type of antenna for local and regional communication. But when it comes to the low angle radiation pattern, we can see that below 30 degrees or below 20 degrees, very low type of a gain out here. It's only 1.4 dB of gain, and probably around 2.6 dB of gain of dipole in 20 degrees, 25 degrees elevation angle. This is not a good radiation pattern for long range communication, because most of the signals arrive within 20 degrees from the horizon. Most of the energy is then wasted in the upward lobe, which is here. We can see that still the gain is very high, 6.6 dBs of gain is there in the upward lobe. Now, how to make this dipole a better acting towards DX communication, right? Just by simply raising the height to 20 meters, which is half wavelength above the ground, we can see that same antenna now has a very good pattern. We are getting 5.1 dBs at 15 degree elevation angle, which is a very, very good sign, right? If we move towards 30 degrees, around 7.42 dB of gain is there. In the broad side of the dipole, perpendicular to the plane of dipole, there is some sort of a good gain, whereas in the ends of the dipole, there is lesser gain in those directions, right? So when we are talking about raising the height, it takes advantage of ground reflections, which are additive to the radiation pattern, and it brings that particular energy. So if we are not able to take advantage of clear ground conditions around the vertical, and if we are not near to the seashore to take advantage of salt water, it practically proves that dipole at a height of more than half a wavelength is definitely a better choice. Now, if you want to even increase this height a bit further, we can see gain advantages, right? Now, if we are at a 30 meters, which is a 3/4 wave length, now we can see that the lobes are forming. There is a significant lobe on the upward direction as well, which formed, which is a not so good for us. But there is a 15-degree lobe now has got 7.68 dB of gain. From earlier 5.1 dB, it has increased the gain by 2.58 dB is increased in that direction. That means, as we increase the height of the antenna, there is a significant number of gain advantage, and there are multiple lobes emerging. For example, this is a one wavelength height antenna. Now we can see that slowly another pattern start emerging. This particular at one wavelength, we don't see a major gain again at 15 degrees, but the elevation of the lobe has lowered, which is a good sign, and there is the upward direction has lowered as well. But one of the significant area out here to know about is We'll bring down the height to around 20 half wavelength once again, and then we can discuss about ground gain improvement with respect to the seawater, right? So we had seen it on the good ground, and now we will see if there is any difference of far field pattern on the seawater. We don't see that much improvement. See, at 15 degree, we will see that we see that 5.2 dB above salt water. If I change the ground to good ground, it should be very similar gain effect there as well. The pattern also looks the same. Ground is also, the gain is also 5.1 dB. That is not a significant improvement. What this indicates is for a dipole antenna, the ground condition just underneath the antenna does not matter that much. That's why dipole always works much better than vertical. So if we are able to clear surrounding obstructions, this is very important, whether it is vertical or the dipole, then the patterns becomes clear, and we will be able to expect the similar performance when we actually go to the field and deploy these type of antennas. Hopefully this gave some idea to you. This is based out of my own personal experience, where I actually had placed vertical in between multiple buildings within a wavelength or so, and then I had to get into a frustration mode, but by not having many signals coming through. The same case was also for the dipole, but I had a very good result after elevating the vertical above nearby obstruction levels to the clear area. Similar thing was observed on the dipole also. So be mindful about the placement of these antennas. That matters a lot. The farther away from the obstructions, higher away from the obstructions, the antenna will perform much better as per your expectations. Thank you very much for listening to me. Hope this will be put in good use for you as well. Thank you.